Yes, it is. Though.
So,
but I mean, there are theoretical theorems that later on. So somebody writes a theorem. Somebody dedicates his life to a theorem. They die at 85. 100 years later, somebody pulls that off the shelf.
Well, that
use to measure
that
X,
is
Y, and Z.
this mathematician that I was talking about.
I mean, that's incredible.
This is what his essay was about: is this the unreasonable applicability of mathematics to the physical world. Quantum mechanics was developed. The mathematics of complex variables was developed long before it had any application on the basis of pure deductions, mathematical deductions from first principles, and then 100 years later, so it turns out to be absolutely critical to doing quantum mechanics. There are many, many examples of this in the history of physics. What is it that why does John Polkinghorne, the great Cambridge physicist, used to say, why does the reason within the mathematics that we develop on the basis of our deductive reasoning match and describe precisely the reason that is built into the universe, the design of the universe? And he says the best explanation for that is, again, theism. It provides a principle of correspondence that the same God who made the design, the rationality, the orderly patterns we see in nature, made our minds in such a way to discern the mathematical structure that is inherent in those systems, and that's why we can do science. And actually, that principle of correspondence was one of the key things that inspired the scientific revolution. It was called the principle of intelligibility. And all the great theists who were the early founders of modern science, Boyle, Kepler, Newton, believed that nature was intelligible and could be understood by the human mind because the design in nature issued from the same intelligence, namely God, who made our minds
in his likeness,
so that we could understand nature.
It's a hell of an argument.